Want to spend a few minutes here talking about the stuff that's going to follow our test. I've already sent out the and I forgot to write that down, but I'll get it here. I've already sent out the problems in our first set of homework for after the test. This will be things we do for Tuesday. These problems involve the notion of divisibility and a little bit of talk about remainders and things like that. So I'm going to throw all that out at you. So let's start by actually defining. This is in your book, but I want to kind of talk through it. I want to talk about the actual definition of divisibility. So if we have a couple of integers, a and b, and a is going to be our non-zero integer. We say that a divides b, and the way we denote that is with a vertical line denoted, put this down at the bottom of the next line, a vertical line b, okay, if there is an integer in such that b is a times that n. Okay, that's what we mean. We can say that a is also, we can say a divides b. We can say a is a factor of b. Let's get the terminology in here. Can also say that a is a factor of b, or we could say that b is a multiple of a. And that's pretty obvious if you look at this, right? What we're saying is b is a multiple of a. We've taken some integer amount of a's and gotten the b. So let me underline multiple, and I will also underline factor. Okay. So, for example, we can say that 4 divides 20. Okay. And the reason that is true is because I can take some number and multiply it times the 4 and get the 20, and of course that number is 5. Okay. The thing I want to point out to you is that we're not looking for a number when we write this. This 4 divides 20 is a logical statement. It's either true or false. It's not searching for that 5. Okay, so let me just make a careful note of that. We do not, I should say do not rather than don't. We do not write things along this line. 4 divides 20 equals 5, for example. Okay, that's not what we're doing at all. We're not actually carrying out an operation. We're making a statement that it's either true or false. It's a logical statement. I'd also point out to you that it does not work necessarily both ways. I cannot say, for example, that 20 divides 4. This is not true. Since I can't take the 4 and express it as 20 times n for an integer n. Okay? We can say something like this. We can say 20 does not divide 4. That's the kind of universal doesn't work sign, right? Put a mark through it. Not equal to, put a mark through it. Not an element of, put a mark through it, and so forth, right? So, just want to stress that the notation we're talking about is not actually dividing anything. We're making a statement that A divides B, or in this case, 4 divides 20. Okay? Now, proofs in this fashion really are going to go, many of them will be direct proofs, many could be proofs by contradiction, but they all kind of work on the same kind of premise, and that is this definition we just showed you. So, for example, I might set out to prove something like this, and this is a very basic example, but let's say that we let A, B, and C be integers, and I'd like to prove that if A divides B and A divides C, then A divides the sum of the two. Okay? So, and this is pretty straightforward. We always, with if-then statements, we always assume the if and then show that the then part has to follow after it, right? So let's let A divide B. Then that means there's some integer out there that I can multiply times A to get the B, right? So then there exists, and I'll use M for my integer, such that B is A times the M. Okay? And we'd also want to let A divide C, then there exists, I'm going to have a different integer this time, N, such that I can write C as A times N. So now what we'd like to consider is, notice that, when we write it this way, the part on the right always ends up kind of over here, right? It's the multiple of the thing we're dividing by. So to reverse this, I want this B plus C business on one side, and then hopefully get A times something on the other. So simply just add B and C. I don't know why I keep saying A. Add B and C. So consider B plus C, which is, and this is just direct substitution, B is this, C is this, and I can certainly factor out an A there. Okay. And we certainly should believe that M plus N is an integer. So since M plus N is an integer, then what we're basically saying here is I've taken some integer multiple of A, and gotten B plus C, which means A divides B plus C. Okay. That's a basic kind of a starting kind of proof, but I mean that's kind of the flavor of what we're going to see there. Let me do another one. Again, let me start with A, B, and C integers. A and B and C are integers. Okay. And the statement I like to prove is if A divides B, then A divides any multiple of B. Okay. Just saying C times B means that, okay, that's some multiple of B. So if it divides B, it's got to divide any multiple of that. And that makes sense when you stop and think about it. But let's actually prove it. Okay. So again, we assume the if part, these are both direct proofs, let A divide B. Then there exists some, I don't know, n such that B is A times n. Okay? Now again, what we'd like to end up with over here is not B, but B times C. Fine. We don't know what C is, but just multiply both sides by C, right? Then B times C would be C times that right-hand side, AN. But of course, you know, with multiplication, we can regroup. This is A times NC. Okay. Now, of course, N times C is an integer. Which means that A divides, here's the A, times an integer gives us B times C. Okay, and that's all we had to show. So these, and I'm giving you a couple easy ones, but I'm showing you kind of how they go. And what I'll have you do in the homework then is go ahead and work out, slightly more difficult problems. We're going to do, this is in 3.1, so here's our homework assignment. And I emailed this to you, but here it is again. 3.1, do problems 2 through, 2, 3, 4, 5, 6, 10, 12. Some of these have some parts to them too. 17, 19, 20, and 21. Okay? So those are the kind of things, those are the problems that we'll try to work in class on Tuesday. If you get stuck on some of these things, contact me and maybe I can talk you through some of them. I think you'll find that most of these are pretty straightforward. There might be a few that you would want to take a proof by contradiction route on them, but still, for the most part, pretty straightforward. Okay? All right, that is the lecture. I'm sorry it's taken me until Friday night to get it posted. We had Ideal Festival today and stuff going on Thursday night as well. So, but here you go, and I will see you in class on Tuesday. Hopefully have everything graded and posted and all that good stuff. See you.